Hi, in this video, we will solve problem meeting rooms type 2 asked by companies like Bloomberg, Microsoft, Facebook, Google, Oracle, and Uber. Now let's check out one problem meeting rooms second version. Okay, so we have solved one version, we have solved merge intervals. Okay, we have solved different problems. Okay, so this is one of the advanced problems on meeting rooms, a bit of secondary version, I will say. But if you have solved some problems, greedy problems, I will say that minimum number of platforms required and minimum number of parking slots required, you can easily solve this problem. Okay, let's see, and we will develop all the intuition and the approaches. Let's see. So, given an array of meeting time intervals consisting of start and end time. So basically, again, this is start time, this is end time, and find the minimum number of conference rooms required. Okay, so we have starting times and ending times of different meetings, and we need to find minimum number of conference rooms required. Okay, so suppose one meeting, as per one example, one meeting is starting from 0 till 30, and the next meeting is starting from 5 to 10, and the next meeting is starting from somehow 15 to 20. Okay, so how many conference room required? So one room will be booked for 0 to 30 meeting, right? And I guess one room only can use for these two meetings, right? Here as well, right? Because one is starting from 5 to 10, okay, and the next meeting is starting from 15 to 20. So till 15 to 20, this meeting will be over and we can use the same room here. So basically, for both the two meetings, we can use the same room. For both the meetings, we can use the same room. That's why the answer is 2, right? 1 plus 1, that is 2. Okay, let's see this case. So we have one meeting only, that is starting from 2 to 7. So how many rooms required? Only one room will be required. Okay, now let's understand how we can solve this problem, understand the different approaches. Also try to relate this problem with the other problem that you have solved. Okay, that merge intervals and all. So let's take the example only. So the one meeting that is starting from 0 to 30, one is starting from 5 to 10, and one meeting is starting from 15 to 20. Okay, so this is one of the case. So how we can solve this problem? Okay, just try to remember that is this problem is basically related to some problems that we have solved so far. Okay, basically what is happening here, one meeting is starting from 0 to 30, one is 5 to 10, 15 to 20. Okay, is there is an overlap between the meetings? Yes, so we have here an overlap. Okay, and here also we have an overlap. So whenever there is an overlap, remember, whenever there is an overlap, we need to book one more room, one extra room. Okay, so for an overlap, okay, if there is an overlap, right, so how many rooms will be booked? Right, two rooms basically, right, one for this one and one for this one. But here you can see, right, here the overlap got over, okay, and again a new overlap happened, right? So it got from 2 to 1, that means one room will be required. Okay, you can see basically here number of conference room required, conference rooms required. So in the overlap, two rooms required. Okay, then from 2 to again 1 because the overlap got over, and from again 1 to 2 because again there is an overlap, right? So whenever there is an overlap, okay, there will be two rooms required. If the overlap got over, it will change to 1, and again like it will change. If there is an overlap, it will change to 2. Okay, okay, let's take some different cases. Mm, let's suppose we have one meeting from this one and one is this one and one is like this. Okay, And if I want to give any numbers, so suppose 0 to 4, let's suppose 2 to 6, 3 to 8, and let's suppose this is 5 to 9, and we have 10 to 12. Okay, so here, right, if I start from here, right, suppose if I am starting from here, let's consider this as a line, like I'm creating one line. Okay, and I'm starting my journey from here. Okay, so I got one meeting, right? Okay, and there is no overlap, right? So number of conference room required will be one. Okay, now let me add the overlap whenever there is an overlap here. So here we have an overlap. Okay, here we have an overlap, this much part. Here we have an overlap with this meeting, and we have an overlap with this meeting too, right? The time is, and here also we have an overlap. This is the overlap. Okay, so basically I started from here, one meeting, like one meeting started, right? How many rooms will be required? Like one room only. Okay, I moved here, I moved here. Okay, one again meeting is started, right? Now there is an overlap, right? Because this meeting is not ended yet. Okay, and one meeting required, right? So think like you are a watchman of a big conference rooms. Okay, or you are a simply who is taking care of all the meeting room, right? So suppose one employee came at 0 p.m. Okay, 0 a.m. whatever, take it as a unit, 0 unit. Okay, and again one employee came at 2 unit. Okay, so again what you will do, you will book one more room, right? So it will change from 1 to 2 because there is an overlap. The first meeting is not ended yet, but the next meeting is started. Okay, now again if you move a little bit, one more meeting is started, right? So again one overlap, one extra overlap, right? So now how many rooms required? Three. At this point of time, if I say at this point of time, how many rooms required? That is three, right? So again, what I will do, I will simply move ahead. I will simply move ahead. Okay, again, three rooms required, three rooms required. And after four, now there is this one is the overlap only, right? This is the region of overlap. So can I say again the meeting that was like three rooms were required, but one meeting got ended, right? One meeting got ended. So now only two rooms required. Okay, two rooms required. And I will move ahead. Again, one new meeting started. Okay, and the two meetings are not ended yet, right? So again three rooms are required, I will go move ahead. And now after six, right, after six again it will back to two, because there is an overlap between these two only. There is an overlap here, right? Okay, so only two rooms required, and now this meeting is also ended at 8, right? So now only one room required, right? From here to here only one room required. Okay, so only one room required, it will go. And at 9 there is now no room required, right? 9 to 10 is a free slot. Okay, 9 to 10 is a free slot. From 10 to 12 again one room required. Okay, and from here in the only one room required. So now you can see at a given time the maximum room required was 3, right? The maximum room required was 3. So can I say the minimum number of conference required will be 3? Conference rooms required will be 3. And how we are solving is, what is the intuition behind? I'm just simply moving in, like from starting times to the ending time, right? I'm just moving from starting time to the ending time. Okay, whenever there is a starting time, I am just simply marking that one meeting is required. I am just like an mm, you can say peon, or a watchman of conference rooms, right? If one employee came at 0 unit, okay, I will simply book one room. Okay, then one employee came at 2 unit, okay, I will book one more room because the first meeting is not over yet. Okay, one again employee came at 3, I will again book one room. Okay, 3 rooms I will book. And one, if one employee is leaving at 4 unit, okay, what I will do, I will simply say that one room is now left. Okay, now how many rooms are booked as of now? That is 2 rooms. Okay, so I am keeping a track of entry and exit time basically. Okay, so this is the basic intuition to solve this problem. Okay, I just want to know that how, like, from where it is starting and where it is ending. Okay, so don't you think like we need to sort the our meetings? Sure, sure, sure. That suppose one meeting is from 0 to 4. Okay, one is from 5 to 9 and 10 to 12, 2 to 6, 3 to 8, right? So I want the starting times. Okay, I want the starting times and ending times, right? So here I'm interested in 0 to 3. Whenever there is a starting time, I am adding a plus, right? And whenever there is an ending time of a meeting, I am simply decreasing my count. Okay, whenever there is a starting time, I am simply adding it. So what I will do, okay, what I will do from these intervals, I will simply take out all the starting times and sort them. So I will sort 0, then starting time will be 5, 10, 2, 3, 5, 10, 2, 3. Okay, and their end times of meetings will be 4, 9, 12, 6 and 8. Okay, but if I sort the data, okay, so it will be 0, 2, 3, 5, 10. And if I sort this one, that is 4, 6, 8, 9 and 12. Okay, and how I am solve this, basically the way I have solved it here, I will take one count variable. Okay, and there I will just check the maximum also. I will update the maximum here, right? So I will take 2 pointers, suppose I and j. Okay, and whichever meeting is starting first, I will take that one, right? So 0 and 4, right? This is basically end time of one meeting, this is an starting time of one meeting. So one meeting is started, right? That is 0, 0 is less than 4, that means one meeting, like, we haven't start time earlier. So what I will do, I will add plus 1, right? Because 0, one meeting started. I will move ahead, then I will check 2, which is less, 2 and 4, which is less, 2 is less. Basically that means we have one more meeting that is starting at 2. Yes, so what I will do, I will update the count to 2 and my max will be 2. Again I will move forward, right? My I will be here. I will check which is less, 3 and 4. 3 is less, that means one meeting again is started. I will update the count to 3 and my max will be 3. Again I will move forward, right? Here I will be at 5. I will check which is less, 4 or 5. 4 is less, that means one meeting is getting ended here, right? Because 4 is less, so one meeting is getting ended. I will decrease the count to 2 and I will move my j pointer. Now 5 and 6, which is less, 5. That means one meeting is started. So what I will do, I will update the count to 3 and I will move my I pointer. Okay, now 6 and 10, which is less, 6. So yes, that means one meeting is getting ended. I will decrease the count and I will move my G pointer. And you can see one meeting is getting ended. What I have done, I have decreased the count basically. Okay, now 8 and 10, which is less, 8 is less. That means one more meeting is getting ended. One more meeting is getting ended and I will decrease the count. Okay, and I will move the pointer. So you can see once you moved from 8, you have only one meeting that is happening, right? Because your count is telling one meeting is happening. From 9 to 10, right? Which is less, 9. That means one more meeting, okay, got ended. Now the count is 0 and you will move your pointer, right? So you can see from 10 to 12, 9 to 10, there was no meeting. That's why the count is 0. Okay, now 10 and 12, right? Which is less, 10 is less, right? So what I will do, I will simply add the count and I will move my I pointer, right? Now, right, my I is totally traverse from all these starting times, right? So I can get the maximum overlap when when there is starting times, right? When there are more and more starting times. Okay. So I'm not considering the ending time. Okay. I'm not checking the ending time because I'm more concerned toward the starting time. Once I have covered the starting time, that means I am I have got the maximum number of meetings, right? I'm more concerned about starting times because suppose, right, one meeting is starting from here, this point, and again one meeting is starting, then again one meeting is starting. So I am more towards their starting point. Okay. And if the starting points are done, okay, my maximum is going to reduce only. Okay. It is not going to increase. So I am more towards about the starting time. Once the starting time is done, I am simply leave it. I will just simply leave it there only. Okay. So yeah, this is how we can solve this problem. Okay. And if you want to know, one edge case is there, can you think of it? If I am applying this, there will be one edge cases. Yes, right. Suppose what will happen? Suppose one meeting is this, one meeting is this. Okay. And one meeting that is ending at here, same time. So we have suppose 0 to 5. Okay. That is 3 to 7. And one meeting is starting from 7 to 12, or suppose that is 14 to 16. Okay. So if you check, you can see here that you might need, or here there are two meetings happening. Okay. But that is not the case. That is not the case. Let me take out one more scenario. Let's suppose we have one more meeting starting from 7 to 10. Okay. So at this point of interval, right, that is 7, you might be thinking that there are three meetings room will be booked, right? Because one meeting is not ending yet. But no, there is not an overlap. First of all, one meeting is ending at 7, one meeting is starting from 7, two meetings are starting from 7. So the maximum meeting rooms will be booked, will be only two, will only be two. Okay. Because one meeting is ending. So don't consider that there are three meetings and at this point there are three meetings at place, so the maximum will be two. No. Basically, again, remember that you started from here line, right? Here only one meeting started, you move ahead, here two meetings started, now the count will be two. And here, right, one meeting got ended, right? Okay. And here one meeting started, one meeting or started, so there are two meetings and one meeting got ended, so the max will be 2 only. Okay. Let's take this scenario and just update the count and max. So basically what I will do, I will start from here 0. Okay. So I will update the count and I will move ahead. I got 3. Again one meeting started, I will update the count to 2 and my max is also 2. Now from 5 one meeting got ended. So what I will do, I will simply decrease the count to 1 and my max will be 2 only. So now from here, right, 7 comma 12, one meeting is also started, one meeting is starting from 7 to 10, but one meeting is getting ended. So first I will decrease the count because this is, right, getting ended. So first I will decrease to 0 and then I will take 7 by 10, that means 1, and then I will take 7 by 7 to 12, then the count will be 2. So the maximum will be 2 only. But suppose instead of not decreasing it first, if I am adding this 7 to 10, then it will be from 1 to 2, and 7 to 12, then it will be from 2 to 3. And then I will decrease from 3 to 7. Okay. So my max will get updated and it will become 3, and which is the wrong answer. So what I will do, instead of starting and meeting, what I will do, I will first decrease it first. Okay. So it was 2 and okay, it was 1. So basically here at 7 it is getting ended. So first I will decrease it and then I will start the new meeting, that is 7 to 10 and 7 to 12. One more meeting started, then my count will be 12. And now at 10 here, when I am reached to here 10, okay, one meeting got ended, I will decrease it. At 12 one meeting again got ended, I will move to 0. and from 14 one meeting again started, so I will move it to 1 and so on, right? So basically, suppose if I am considering my start array, right, where we have starting time, so I will have 0, 3 and 7 and 7 and 14, okay, and end time where I will have 5 comma 7 comma 10 comma 12 and 16, right? So if I am taking these two, right, suppose I and j, okay, so which is less? 0 is less, I will update the count 0 to 1, my max will be 1, okay. Now 3 is less, so one more meeting started, my count will be 2. Now here 7, right, I have 7 which is less, 5 is less, right? So what I will do, I will decrease the count to 1 and I will move ahead. Now both are 7. So instead of adding it, I will first solve this one, right? Ending meeting. So I will solve the ending meeting. It will be moved to 0 and I will move my j pointer. Then 7 is less. What I will do, I will update to 1, will move I, and again 7 is less. I will update to 2 and I will move I. And this is how basically I will solve this problem, right? So yeah, this will be basically the approach of it. Okay. And this is how we will solve this approach, this problem. This is exactly same problem like your minimum number of platforms. If you don't know, I will tell you. Basically, in minimum number of platforms, we have different starting and ending time of the trains. Right? Start time is given, okay, and end time is given of trains. Okay, and you need to find out minimum number of platforms required. Right? So suppose one train is coming at 6 a.m. and leaving at 8 p.m. Okay, so instead of 6 and 8 here, one meeting is coming at 6 a.m. and leaving at 8 a.m. Then one train is coming at 9 a.m. and it is leaving at 3 p.m. and one train is coming at 10 a.m. leaving at 2 p.m. So basically what you are doing, you are finding out like what will be the minimum platform required if these are the starting time. Similarly, this is also like how many parking slots will be required in a mall. Suppose you know the timings of your car, okay, how many cars are coming and what will be the timing of their entry time and exit time. So basically you will find out the how many parking slots will be required. Okay, this is also one way to solve this problem, exactly same question. Okay, so now let's check out how we will write the code of it. So I will write the pseudo code. So here if I write a completely pseudo code of it, it will be very simple. Basically, in these start times, what you will do, you will simply take out the, you will simply map it. So simply you will map the intervals. So I will say that suppose we have intervals, okay, you will map it, okay, and you will map each interval with its like starting time here, and then you will sort according, simply sort it. Basically if you sort it, you will get the answer like ascending order, and here suppose we have an ending with intervals, I will map it here as well, but with their end time. So instead of I comma 0, it will be I and 1. Okay, and I will sort it. Remember that if I'm using sorting, I will use the same thing, that A comma B, A minus B, basically from increasing order, in an increasing order. This is done. So what I will do, I will take one result, or I can take suppose max. So simply the maximum time, yeah, maximum meetings required. Max will be starting from 0. I will take one count that is also starting from 0. I will take two pointers I comma j, both are equals to 0. And while, okay. So I am more concerned that I have already looked, I am more concerned about the starting time, because only the starting time will help to increase the number of conference rooms. Okay, ending time won't increase the number of conference room, right? So once the starting time is done, I will simply say that done of the loop. So I less than intervals dot length, what I will do, I will simply write if my starting time is less than, so start of I is less than the end of j, what we need to do basically, I need to do I plus equals to 1. Okay, and the next thing will be update the count, so I will update the count. Okay, in the else condition, what I will do in the else condition, so here in the else condition I am also mentioning that case when there is an equal, when starting time and ending time is equal, right? So that will also come under the else case. Basically I will move my j pointer and I will decrease the count, so count minus minus, right? And here, right, in the max I will simply find out the max of it, so max of count and the max that we have taken. So basically this is method dot max, and here in the return I will simply return max. Yeah, so yeah, this will be the pseudo code of it. And if I tell you about the time complexity of it, so here there are intervals, so you are taking n log n. Okay, let me take it capital N log n, here as well n log n. Okay, and this will run till the n intervals, so this will take n time only. And yeah, so the time complexity here will be big O of n log n plus big O of n, and the overall time complexity will be then big O of n log n. And what about the space complexity? So we are not taking any extra space, we are taking only two variables, so space complexity will be big O of 1. Okay, so yeah, this is how you can solve this problem efficiently with time complexity and space complexity. Okay, now let's discuss one more approach to solve this problem. Okay, let's discuss the approach to where we will use some data structure, because in Java we are provided with some very beautiful data structures, that is priority queue. So we can leverage that data structure here, and let's try to solve this problem. So again, what I will do, I will take the two cases exactly seen these problems. So suppose one problem was from 0 to 30, and 5 to 10, I guess 15 to 20, and in this was the first case. In second case, one meeting was starting from here. Okay, one was starting here somehow, and one meeting was starting here. Okay, so 0 to 4, we'll say that this will be suppose 2 to this will be from 5 to 10. I can put 2 to 6, 3 to 8, and suppose 12 to 16. Also, let's take one more scenario when we have meetings from 0 to 4, then 5 to 10, then 12 to 16, and one meeting is in here and one meeting is happening here. So 0 to 4, 5 to 10, 12 to 16, and here let's suppose that is 3 to 6 and 8 to 14. Okay, yeah. So apart from the last approach, is there any other approach that you can think of how we can simply solve this problem? So if you can remember in the merge intervals, basically we merge the entire, like if there is an overlap, and that merge basically tells the non-overlapping intervals, right? So basically what we were doing in merging, we are merging these intervals whenever there is an overlap, like here we have an overlap. Okay, here we have an overlap. So what I was doing, I was simply merging it. Okay, and we are coming within one interval. Okay, like here will be 0 to 30. Okay, also when there are different cases, so what we were doing, we are merging it. Okay, and we are coming with a series of non-overlapping intervals. This is very important. In merge intervals, the question, we are coming the series of non-overlapping intervals. So the series of non-overlapping intervals telling that only one room will be required for all the meetings, right? Basically, if there is a series of non-overlapping intervals, can I say that there will be only one conference room required for all the meetings when there is a no overlap? Right, right. Okay. So what is the intuition here? Basically, let me put that this is an overlap, and here to here we have one overlap. So basically, again, we will use stack data structure like we have used in merge intervals. And here we are more concerned about the which meeting is ending first, right? So basically, if I want to work on the minimum conference required, I want minimum conference rooms should be required. Okay. So from all the meetings, right? From all the meetings, so 0 to 4, 2 to 6, 3 to 8, I will be more concerned which meeting is ending first, right? So suppose like here at this point of time, 0, suppose one meeting starting from 0 to 4. Okay. Then before ending, one again meeting started from 2 to 6. Okay. So what I will do, I will book one more conference room, the first one, the second one. Okay. And before ending, one more meeting is starting from 3 to 8. Okay. So I booked three conference room. So here always I will always be at this point whenever which meeting is ending first. So in 0 to 4, 2 to 6 and 3 to 8, this 0 to 4 is ending first. So I will always take care of which meeting is ending first. Think like a real scenario, right? Suppose you are a peon or you are watchman, right? And there are three meetings happening, and you, like the person or the manager told you that please try to book as less number of slots, as less number of conference room. So you will be more concerned about which meeting is ending first. If three meetings are going at a particular time, you will be more concerned of which meeting is ending first. So I will be more concerned of 0 to 4 is ending first. Okay. Now, now once this 0 to 4 end first, like here, if I am getting a one more new meeting, suppose 5 to 10, I will check which is, like here I know that this meeting is first, and can I add this meeting in the first room? Yes, you can add. So what I will do, I will simply remove this meeting 0 to 4, and I will add 5 to 10. Okay. Okay. Now again I have three meetings, 5 to 10, 2 to 6 and 3 to 8. So again I will check which meeting is ending first. This meeting is ending first. So I am more concerned about 2 to 6. I will be at 2 to 6. Okay. And if any new slot is coming to me, right? Suppose this 12 to 16 is coming to me. I will first give 12 to 6 here. Right. So I will remove this one. I will remove 2 to 6. Right. And I will give a slot of 12 to 16 here. Right. And during this, I will just basically find how many meetings were there, like one there in the stack. Okay, let me tell you. Let me tell you with the real example. Let's see. Let's try to solve it. Okay. Let's let's understand with some examples. So what I will do, I will create one stack here. This one, and let's see. Let me just get. Okay. So suppose one meeting started right from 0 to 30. So what I will do, I will simply store the end time of a meeting here. Okay, that is 30. Okay, so I will store the end time of a meeting. Let me use different pen. So instead of with this, I will simply store in a stack 30, and my stack size will tell the number of meetings that are happening. Okay, so 30 I use stored it. Okay, and now the next meeting is starting from 5 to 10. So I will check, right? Can I place this meeting, right? Is it possible that can I simply place this meeting? But no, it's not possible because 0 to 30, one meeting is already running, right? So here from 5 to 10, you need to take one more extra room, right? So what I will do, I will add this also into my stack, right? So I will add the end time here, and I will add this also into my meeting. Okay. And I will always look which is the first ending time of my meeting, right? Which is the nearest ending time of my meeting. Okay. Earliest ending time. And 10 is the earliest ending time of my meeting. Okay. Then I will check 15 to 20. Okay. I got one more meeting, 15 to 20, right? So see, 15 to 20. Do I need to book one more room for 15 to 20 meetings? No. The last ending time is 10, right? So what I will do, I will simply remove this one, 10. Okay. I will simply pop out 10 and I will add the last meeting ending time, that is 20. And yeah, that's three meetings are done, right? So the maximum size of my stack is 2. So the total number of meetings required or conference room minimum required will be 2 only. Okay. So yeah, let's take one more case. Okay. Suppose instead of this, let me take the second case. Basically, remember what I am doing here. Okay. What I am doing here. If there is a no overlap. Okay. Like here 5 to 10 and 15 and 20. There is a no overlap. So what I will do, I will simply remove this meeting and I will add the new one. Because there is a no overlap, right? So I will simply remove this one and add the new. But if there is an overlap, so I will add the meeting in the slot in my stack. Okay. So one meeting is starting from 0 to 4. Suppose my high point is here. One meeting is starting from 0 to 4. So I will simply push 4 into it in my stack. Okay. And now next meeting is starting from 2 to 6. Right. So what I will do, I will push 6 into my stack. Okay. But this is my not stack, right? This is a special stack that is used in Java. So this is a priority queue. Priority queue. So basically what priority queue does, basically it sort itself. So basically it sort itself and it will change from 4 to 6 to 6 to 4, right? So 4 will be come here, 6 will be come here. And why I'm sorting it? Because I should my peak element should always be the earliest ending time. Okay. My peak should always be point to the earliest ending time. So 4 is the earliest ending time. Okay. So this 2 to 6 is done, right? My I pointer was here, 2 to 6 is done. Now new meeting is starting from 3 to 8, right? Is it possible that I can place 3 to 8? Okay, no, that's an overlap. Okay, so what I will do, I will add the 8 also in my priority queue. So if I add 8, again this data is like this data structure will be distort. So priority queue basically sort itself, and again my peak element will point to the earliest ending time. So it will point to earliest ending time, that is 4. Okay. Now again one meeting is happening, that is 5 to 10. Now is 5 is greater than 4? Yes, it is. That means okay, one meeting is end, then the next meeting will happen. Right? Yes, 5 is greater than 4. So what I will do, I will pop out 4 and I will push 5 here. Push 10 here. Ending time. Remember, I am always pushing the ending time. Again my priority queue sort itself, right? So if my priority queue sort itself from 10 6 8, it will become 6 8 and 10, right? My priority queue will points to the earliest ending time. Okay, now I am getting next meeting, that is 12 to 16, right? Is it possible to place this 12 and 16, right? 12 is greater than 6. Yes. So yes, I can simply remove this meeting and add the new one. So basically what I will do, I will pop this one and I will add the 12. And again this is my priority queue, so it will sort itself. So it will sort itself and it will become 8 10 and 12. So what is your priority queue size? That is 3, and so the answer will be 3 only. Okay. Yes. So remember, like when I will always check the which meeting is ending first, right? Earliest ending time. Okay. And if any meeting starting time is greater than the earliest ending time, what I will do, I will simply pop it out and push it there. Let's again understand with one more example. Let me put this tag here, my priority queue, and let me remove this one. Okay, this answer is done. Okay, and let's see. So 0 to 4, when my meeting is happening from 0 to 4, I will push the ending time here 4. Okay. Again, one new meeting is starting 3 to 6. So I will push the ending time here. But before that, I will check, right? Is 3 is greater than 4? No, that means I need an extra room. So what I will do, I will push it the ending time here 6. Okay. And again, this is a priority queue. So it will sort itself. So it will again on the top it will be 4 again, because it will simply my peak element tells the earliest ending time. Okay, now again one meeting is happening, that is 5 to 10, right? So is it possible that 5 to 10, 5 is greater than the earliest ending time 4? Yes. So the new meeting simply can happen, right? So after one meeting ending, so what I will do, I will remove 4 and I will push 10 here. Okay, again my priority queue will sort itself, so it will point to my earliest ending time 6 to 10. Okay, now I am getting a new meeting that is starting from 8 to 14, right? So 8 is greater than the 6, the earliest ending time. Yes, so this meeting will end and I will push the 14 here, right? So I will push 14 here, and again, right, it will be sort itself, so 10 come at the top and 14 will come at the down. Okay, now again one meeting is starting, that is starting from 12. So is it possible that new meeting will take an extra room? No, it won't take the extra room. My earliest ending time is pointing to 10. Okay, and 12 is greater than 10. So basically what I will do, I will simply pop out 10 and I will push 12 into it. Okay, now I pushed 12 into it. Again, my data structure will sort itself. Okay, so it will become, yeah, it was 12 and 14 only. So yeah, it will be here, and yeah, that's the end of it. So basically what will be my size is 2 here, and the answer will be 2 here. That minimum conference required will be 2 only. Okay, so basically here what is happening, there are two things happening. Okay, I am popping out the elements. Okay, popping out the elements, and second, when I am pushing it. So let's see, when I am popping it out, whenever start time, okay, is greater than the end time, so what I will do, I will pop it out, because my new meeting start time is greater than the end time. That means this peak end time, I will say, my peak element end time or peak interval end time. That means one meeting is ending, then the next meeting is starting. So what I will do, I will simply remove it, or suppose if it is equal, then also, right, I will simply remove it and then I will add it. Okay, now when I am pushing it, okay, when I am pushing it, be simple, whenever the start time is less than your peak, you will push it. Okay, so if you start time of the new meeting right here 3,326, start time is less than the peak end time, the peak was only 0 to 4. Yes, so what I would did, I simply push it, because one more room is required. Yes, so basically this will be approach, this is helped, this is possible through priority queue only. Okay, so what I will do, I will write the pseudo code of it. Okay, and we will understand the time complexity. So basically here also, see, if the data is not sorted with the in their time, so I won't be able to find the overlap, right? I need to find start time is greater than the peak ends time. So always here also, what I will do, I will simply do the sort. So I will do arrays dot sort, okay, according to their start time, right? Then what I will do, I will create one priority queue. Okay, that is inbuilt in Java. Okay, that is given in Java. But in JavaScript, if you want to do it, you need to sort the array. Simply, you will take the stack. You need to sort it again and again, again and again, so that it will work. So I will simply basically create one new priority queue like this. and simply I will start the intervals. So from interval, I will start it. Okay. So now whenever my peak, if my suppose, if my, first of all, the stack should be not empty. Okay. So I have the priority queue should not be empty. I am saying it priority stack. Priority queue should not be empty. So if my priority queue is not empty, okay, and my priority queue peak, okay, my priority queue peak is if it is less than equals to your intervals 0, or basically if I say starting time is greater than equals to end time, na? So intervals starting time, that is 0, if it is greater than equals to your priority queue peak, then what I will do, I will simply, what I will do, if it is greater, I will simply remove it, right? So I will do p dot poll, or you can simply do p dot remove, all things will work, right? Okay. And after this if condition, what you will do, you will simply add the interval and the time. So I will say intervals and the time, and that's it. That's the whole code. Okay, that's it. After the for loop, I will simply return the p dot size, my priority queue size, right? So yeah, this helped here, right? That's a short code, and here the time complexity will be big O of n log n, and here this will run for n times. Okay, but what you are doing, you are adding here, right? This is add interval, you are adding here. So adding and removing take in JavaScript in priority queue will take log n times. So this will take whole big of n log n, okay, plus big of n log n of sorting. So the overall time complexity here will be big of n log n only, and space complexity will be big of n, because you are taking one priority queue and the maximum size can be up to n, total number of. The same question if you want to do in JavaScript, right? So what you can do, you can take here stack, you can take here stack, and what you will do, you will basically, if there is an empty and your interval is 0 greater than, what you will do, you will simply remove it, the peak element. You can say your p dot pop, you will remove it and you will push it. So that is also fine. You can simply push it, the element. But whenever you are pushing an element, always do one extra thing, because you don't have the priority queue this thing. So what you will do, like once you have added, you need to sort it also. So you here you will do p dot sort simple a comma b minus a, because the least element, okay, in descending order, in descending order, because the interval with the least time you will put at the top, the interval with the earliest time you will put at the top, so in the descending order. So in that case also you can solve this problem. Okay, so yeah, these were the two approaches. I have discussed both the approaches with the data structure. In the next video I will show you the code implementation of the part. Okay, so yeah, see you in the next video.